6.1 Introduction to Integers. Just so you understand, when we say integers, what we really mean is negative values, usually, okay? Because this is the first time we're going to see the use of negatives, and then we're going to start operating with them as well, which we'll see in the next section. So, negatives and positives. Opposites refers to signs, and that's negatives and positives. We should be at least a little familiar with negatives. I know we haven't seen them yet, but negatives, we would use this sign right here. It's just kind of a flat, straight line right there. It's generally in the middle of a number. So, like, if I wanted to demonstrate -8, might be like in the middle there. Doesn't really have to be this long. Maybe it's getting more technical than you'd like it. And then positive numbers, like we've seen, an opposite to a negative would be a positive. So if we looked at -8, its opposite would be the same exact number, 8. It's just now without the negative. Okay, so this would be positive, which we've seen. We've seen lots of positive numbers. We don't usually show the positive symbol. I suppose you'd be okay to do that by hand if you'd like, but generally speaking, we do not show the negative sign right there with the positive numbers. Okay, but opposites. This is an example of opposites. Okay, so if I said, what's the opposite of a negative? It'd be a positive. What's the opposite of a positive? It's a negative, and then so it kind of circles around like this. But the number itself does not change. It's just the sign is changing. Okay. So in this first example, find the opposite of 12. So again, the number itself does not change. I would keep it as 12, but this one would be positive 12 right there because it's not showing the sign. And like we've seen again before, again, that's better. We don't usually show positive signs with positive numbers. Okay, so if I wanted the opposite to that though, then I would make it a -12. So once again, the number doesn't change, it's just the sign does with opposites. Or if I looked at -12, once again, its opposite would be 12 still, but the sign changes from a negative to a positive. And yeah, we don't usually show that positive symbol there. So it would just show us 12. And by the way, just like we've seen before as well, when we see these numbers, we don't usually declare that they're positive, but now that we're dealing with negatives, maybe good practice until you get used to it. Yeah, I wouldn't say, hey, this is positive 12. I just say 12. -12 and 12. Those are opposites. Again, you're welcome to say positive 12 as well. Now, the opposite of 0, though, 0 is not considered positive or negative. So if I said, what's the opposite of 0? You'd just say, well, 0 itself is its own opposite. Again, it doesn't change its sign. It's just because it has no value, so it's the only number that we have that it's its own opposite. Okay? But you can't change the sign of 0 because, well, it has no value. All right, so integers are whole numbers, and whether we've talked about whole numbers or not, the lowest one we have is 0, and then it's just counting numbers from there, 1, 2, 3, and then this goes on forever. So these three dots indicate that this pattern continues on and on forever, but you'll see with whole numbers that there are no decimals. Okay, so this is classified as whole numbers. Integers are all the whole numbers, but also their opposites, which is what it's saying right here. So again, you wouldn't show the opposite of 0 because it's its own opposite, but you could show the opposite of 1, which is -1. You could show the opposite of 2, which would be -2. You could show the opposite of 3, which would be -3. And this pattern, again, it continues forever to the left. Now, this is important the way that I have this written because when we look at number lines in the future, generally they're horizontal number lines like this. And if you put 0 right in the middle, the positive numbers are to the right, and then the negative numbers are to the left on this horizontal number line. Are there such things as vertical number lines? Yes, there is, but we'll discuss that later on, okay? And then each of these, each marking can represent 1, maybe 5, and then to the left you'd have -1, -2, -3, -4, -5, and this pattern continues on these number lines. We'll see number lines as well. Now the number line will be important when we start comparing numbers, but we'll get to that. All right, so negatives. There's our negative symbol. We've seen it. It's the opposite of positives. Negatives are to the left of 0 in the number line, which we just saw. Maybe I jumped the gun on that. So there's 0. Again, if this is 1, its opposite would be -1. So opposites, by the way, they're the same distance away from 0. They're just on the other side of 0. That's all. So like I said, hey, here's 2, and then its opposite would be -2. See how it's, well, if I draw this better, it's the same distance from 0, just on the other side of the number line. And yeah, again, to the right, you get more positive values, and to the left, the numbers get even more negative. And when we say more negative, it's just like it is with positive numbers. The number gets bigger, but for negatives, the number gets bigger. It's just going to keep that negative symbol with it. So sign numbers can be used. Generally, money is the most, well, it seems like it's the most effective way to use with college students. Uh, when we get into K through 12, talking about money sometimes is not as it's not as effective because, well, they don't have any experience with money. Temperature sometimes it's a little bit more effective, but it's definitely in college again it's a little bit more helpful. Elevation and direction is useful, but usually in a pure mathematical sense. But when we talk about money, generally that's when students are like, oh, yeah, I get that. And so if you prefer to think about these in terms of money, then feel free to do it. Just remember that negative numbers with money is debt. Okay, positive numbers we don't usually say it's credit. It's just money that you have. That's kind of how I demonstrate it. Temperature below 0 degrees, and positive numbers would be above 0 degrees, of course. And so there you go. There's that vertical number line thing. That's a thermometer, right? If you go back to, well, when I was a kid, we used to have those thermometers that were filled with mercury, and then we thought it was funny to break them and then kind of jab our friends with those broken glass things, but we turned out okay, I suppose. But in any case, below 0 degrees, and for temperature, by the way, it doesn't matter if you're using Celsius, centigrade, or Fahrenheit. When you get below 0 degrees, then you're looking at negative temperatures. When you get above 0 degrees, you're looking at positive temperature. I'm not talking about freezing necessarily. It's just above and below zero. That's all. Elevation, of course, negatives would be below sea level. Positive numbers are above sea level. That's it. Okay, and then with direction, negative numbers generally we'd say these go down, um, or they're losing value. Positive numbers they go up. But again, that would be demonstrating this with a vertical number line, not a horizontal one. So when we look at the horizontal number line, negative numbers would say be going to the left, positive numbers go to the right. That's the only difference there. So that's a little quick introduction to negatives, which are uh, uh, certain types of integers. But hopefully, with some more examples, we'll see exactly what we're talking about on these. And this hopefully helps you to understand negatives and not necessarily where they come from, but what they are at least. So this is a good introduction. All right, express the amount as a positive or negative integer. So just positive or negative number. I think that's redundant because integers are positive or negative. Doesn't matter which. Do not include dollar signs in the final answer. So we don't want to label this. That's going to bother the crap out of me, but I'll get by, all right? Tina overdrew her bank account by 74 bucks. So the number's not going to change. We're still looking at $74 here. And again, yeah, I want to label that so bad. But we got to be able to figure out the sign. That's all we're really doing with this. By determining is this value positive or negative. Well, since Tina overdrew her bank account, so overdrawn, I don't know that this vocabulary is even used necessarily with bank accounts these days. Usually it's like, well, I used a credit card, so, well, and credit cards, generally speaking, always represent debt. So overdrew is kind of the same thing here. It means that she had taken her account to zero, and then she went past zero to $74. And by past, I mean to the left, right, on the number line, which would indicate that we're dealing with a negative value on this one. So again, it's hurt me that I'm not labeling this, but I'm going to keep it this way. 74, but negative 74 because it was overdrawn. And again, that may be some vocabulary that you're not familiar with, but um, you'll find out pretty quick on the assignment which is which. Express the amount as a positive or negative integer. The hottest recorded temperature is 134 degrees Fahrenheit. So again, we're looking at the same number here. It's still a 134 on this. That's not going to change. You just got to figure out if it's positive or negative. Since it's the hottest temperature, we should know that we're dealing with positive values on this. So it'd be above zero on the number line, right? Like if this is our thermometer, you'd have zero right here, perhaps, and there's 100, so 134 would be about right there, perhaps. I don't know, something like that. But it's definitely above zero, which means that you're looking at positive values. If you went down below zero, then you'd be looking at negatives on that. At least that's the way those old thermometers work. Oh, the last thing on this one too, yeah, you wouldn't actually show the positive sign. You would not need to type in the positive symbol on the assignment for this. Express the amount as a positive or negative integer. Same thing, but this says the canyon is 472 feet below sea level. That we'll get to that, but remember the number's not going to change. Still 472. We just got to figure out if the symbol is positive or negative right there. And on this one, we're specifically talking about below sea level right here, right? Below would indicate that we're, well, below zero, which would indicate that we are in the negatives. So as an altitude, as a height, however you want to look at it, just compared to sea level, which is considered zero, this is below it, and below would indicate a negative. So negative 472. Again, I want to label that feet. I'm not going to because we didn't label the dollar, so I'd feel weird if I labeled this one in feet, but negative 472 should work. Place the numbers 3, negative 8, and 6 on the number line below. Now remember, this will be important once we get to ordering the numbers from least to greatest, which we will do. But again, on the number line, numbers that are farthest to the right are considered bigger than numbers that are farthest to the left. So you may see a negative number that may seem like it's bigger, but actually the more negative it is, the less its value is. And talk more about that later. But let's place these three values here on the number line. I'll try to color code them. 3, I'll do this dot in red. And so I just need to find, I usually start mentally from 0, and then I say, well, it's 3 away from 0, 1, 2, 3. Boom, there it is. And so there's my first dot out there, 3. Okay? Now I went to the right from 0 because we are looking at a positive 3 right there. So I knew to go to the right. Whereas negative 8 here, that's negative. So I would start at 0, and I would know I need to go to the left 8. So starting from 0 now to the left, because it's a negative value, 1, 2, 3, 4, 5, 6, 7, 8. And that's where my second point would be. I'm going to put this one in purple. Boom. Negative 8. Okay? Now, of course, these are all numbered. I mean, they're labeled for us. So, like, if you don't like to count or if you don't need to count, then you don't have to. Of course, you just find 6. Oh, there it is. I find the matching 6 right there. Not negative 6 right there. I mean, there's another 6 there. It's just negative, but this is positive 6. So again, you just want to make sure you're on the right side of 0 when you put these dots here. And that's all you need to do on the assignment. You just click here, here, and here. It doesn't matter what order. You can go least to greatest, greatest to least. You can do them out of order. It doesn't matter. It'll accept the answer either way. It just wants to see those 3 dots in the accurate spot for that number line. Now we've seen placement of dots on number lines with values that are given. So the 3 and 6 should be no surprise. But now that we're dealing with negatives here, that again, it shouldn't be a huge surprise. Just finding the value on the number line. That's all. But again, just to kind of skip a little bit ahead here, if it says, well, list these numbers from least to greatest, you do negative 8, 3, and 6. Least to greatest because negative 8 is farthest to the left, and then you move to the right on the number line for least to greatest. So this is an absolute value symbol right here. Now there's usually a number in between them, so don't get this mixed up. Like if we show this where the two absolute value lines are closer together like this, then we usually read that, oh, that's 11 right there. But there usually is a value in between, so don't worry about them being close together like that. Now, also, we tend to make these a little bit bigger than the number. So, if I said the number 5 right here like this, this would read the absolute value of 5. Now, that's a lot of words for just a few symbols, but that's what this is saying right here. So mathematically, that's how we read this. Now, of course, we read it in a different way, which we'll get into, but it's important for you to understand when you see these symbols, we're not looking at numbers. And you can see down here in this example even, the number 1 generally, especially with typing like this, it's shown differently than just a straight line like this, which is what I do when I write it by hand. But it's important for you to be able to tell the difference. So even when I do this by hand, you'll see me kind of exaggerate the two absolute values, and then I'll put a number in between it like this, okay? Now, what is an absolute value? Well, an absolute value is the distance a value is from 0, specifically the value that's in between the absolute value symbols, okay? So like up there at the top, I'd say that's the absolute value of 5, or it's really asking what is the distance from 5 is from 0. How far is 5 from 0? Now, in answering this question, how far away is a number from 0, it's important to think of this as a distance. Okay, distance. How far away is the distance from 0? And one of the questions you should want to ask yourself is, do you ever represent distances in the negatives? Now, if you do, it's possible you may have a very good career in politics later on, but generally speaking, we don't use distances with negatives. For example, you would not say that I live negative 40 miles south of Salt Lake City. You would not want to do that because, what the crap are you talking about? You'd say I just live 40 miles south. You'd say I live 40 miles north of Salt Lake City, right? Which is more direct. So absolute values essentially get rid of the negative and make it a more direct measurement, which would be in the positive. So like in this example, it's saying, well, how far is 17 from 0, right? This is the absolute value of 17. Well, 17 is just 17 from 0. That's it. Okay, these are not opposites. Do not get this confused with opposites. That's the most common mistake we see when we start introducing negatives and absolute values like this. Students start saying, well, it's an opposite, right? No, it is not an opposite. Absolute values are distances from 0, which means that they should always come out as positives. So here we have 4 examples, and yeah, you can have absolute values of fractions, decimals, negatives, positives, doesn't matter. We can always find the absolute value of some numbers. So I'm going to start with the top here. So this is the absolute value of negative 8. Okay. So this is really asking, see if I can type this in here, how far is 8, negative 8, fix that. How far is negative 8 from 0? Good question. Well, how far away is negative 8 from 0? It's 8 away from 0. So it's just a straight 8 on that, okay? So it didn't change the value, it did change the sign, but again, we're not looking at this as opposites. It's distance, which should always be referred to in the positive. That's positive 8 right there. Let's go ahead and jump to this fractional value. So this is the absolute value of negative 9/4, which again, is just asking how far away is 9/4 from 0. Sorry, let me restate that. How far away is negative 9/4 from 0? Jumped ahead of myself. Negative 9/4 is, just 9/4 away from 0. So it's just a fraction right there. But it's positive because, again, it's a distance, and we only refer to distances in the positive. Well, what does that mean for these two? So let's start with the top one. That's negative absolute value of 20. Now think about this, okay? It's the negative absolute value of 20. And while I did not say this before, because we haven't covered it so much so far, is that absolute values are classified with parentheses. Okay, that's an order of operations thing, which again we haven't gotten into, but we will. Or if we don't, then in the next class we will. And on this one, we'd say, well, the absolute value of 20 first. I'm saying we're going to do the absolute value first, and it's just the absolute value of 20. So how far away is 20 from 0? It's 20 from 0. Now, I would look at this negative here, and made it green, and I would apply it to that 20. So it's the negative absolute value of 20, and the absolute value of 20 is 20, there in purple, but it's the negative of that, so it's negative 20. So do not get this confused with the example that we did up here on this one. This was the absolute value of negative 8. This one's the absolute value of 20, but it's negative. There is a big difference right there, and I'm trying to phrase that specifically in a way that you can understand the difference on those. Okay. So what about this one? It's the negative absolute value of negative 88. So again, I say, hey, look, start with the absolute value first. Can you tell me the absolute value of just negative 88? Don't worry about this negative here. Okay, so how far away is negative 88 from 0? It's 88 from 0. Okay, so that's where this orange 88 comes from. But then again, we got this negative on the outside, and that's crucial that it is on the outside, which means it's the negative of that absolute value, and the absolute value was 88, so we're going to take the negative of that, negative 88. So there's a difference between these. Generally speaking, we don't see a lot of mistakes with the top one here and the bottom one, even with the fraction. It's once we start seeing negatives on the outside that we start to see students make mistakes. So be very careful on that. It's important to understand the absolute value. You need to do that first and then apply negatives, any negatives on the outside. So negatives of negatives. So if you ever see like negatives being applied to negatives, just understand that negatives of negatives are positives. Okay. Now this goes to the old phrase that two wrongs make a right. As far as I know, that's only true in like pure mathematics like this. Wrongs being negatives, of course. So if you ever see double negatives applied the way that we're going to see them, then just know that you're looking at positive values, or that the answer ends up being positive. Now you'll see this is a common pattern, even when we get into 6.2 with adding um, with negatives. But the first thing you're going to want to do is just to determine the sign of your answer, and then you can start working with the actual numerical value, okay? But if we can just figure out if an answer is positive or negative, it usually is half the work, even though, of course, there may be a lot of operating. But if we can just figure that out, then the rest of this generally makes sense pretty quick. So it maybe helps to actually change the sign in some of the problems. Yeah, we'll see that. So what we're talking about here is sometimes you'll see negative values in parentheses, especially when we see the addition in the next section. So let's look at -4. Okay. Sometimes you'll see it in parentheses like this. It's just the parentheses is just kind of help us to see the difference between. Usually it's operations, but sometimes what you'll see is something like this, like -4 like this. Okay. Now these two are different. I'm showing two different things here, but you'll see right here. If I were to take away these parentheses like this, you should probably ask yourself, what the crap is going on with this negative? I mean, are we looking at negative signs? Are we looking at minus signs? What the crap is this? Well, the parentheses take away that question, and then we say, oh, it's a -4. Now, negatives generally communicate opposites when we see doubles or triples or anything beyond that. So this would be like saying, well, what's the opposite of -4? Which we know opposites, right? The opposite of -4 is +4. So that's how this comes out as a +4 like this. Now, there is something to be said about continuing with negatives, but of course, it's going to show more parentheses like we'll see in the first example on this next one. All right, like this one here, okay? The -153. All right? Now, remember that a negative and a negative like this, when they're applied this way, especially with parentheses, would indicate that we're dealing with positive. So on this one, it doesn't matter which two you choose, but I would say that look at these two right here. Those two negatives right there are going to be a positive. Now, sometimes I'll even do this. I'll just kind of cover with kind of a big plus sign right here, just kind of show that I've pretty much taken those out. And what this does is, remember, with positive signs like this, we don't generally show those, so it kind of takes that away right there, and that would essentially take away that parentheses as well. So, well, what are we left with after we take away that positive? Well, yeah, all I can see here is that I'm left with 153. Okay, so and that is the answer, by the way. So this brings up a different concept as well for us. Okay, let's see if I can figure out the technology on this. There we go. That positive right there. Let's go back even further and look at the original problem. Well. So one thing that you'll need to understand, and this is jumping a little bit ahead of us, is that these three negatives, the 3 is odd, and so we would know that the answer is negative. Okay, and if you ever see negatives in a string like this, if you can understand that an even number of negatives, like we see on this next example, produces a positive answer, like this one would be +7, then you're well on your way to doing multiplication and division with negatives. But see, on this one with the 3 negatives, that's odd, which then made the answer a negative. And so when we see them again in a string like this, you just need to determine, in order to figure out if your answer is positive or negative, if there's an even or odd number of negatives. But more on that later. For now, this is as far as we need to go on that. All right. Well, this isn't my best handwriting right here, but it should help. Okay. So on this one, now remember I was saying on like we talked about on this one, the first thing I would do on this in order to determine if my answer is positive or negative is just see how many negatives there are. And on this one, I'd say, well, there's 1, 2, 3, 4, 5, 6, 7 negatives, and I know 7 is odd, which then should make the answer a negative. So this would be negative 10. Of course, there's no other numbers in this, just 10. But the other way to do it is the other way that we looked at it. I'll demonstrate that here. These two negatives become a positive. These two negatives become a positive, and then I'd say these two negatives become a positive. Well, see how you're left with that positive, the negative right there, which was part of the answer right there. So again, all these negatives right here, they pretty much just they go away. They become phantom signs, I guess, or cancel each other out. However you want to say that, and yeah, now we're just left with that negative 10. So here's the objective here I can use on this part anyways. I can use, that's the less than symbol in the first one, or greater than symbol to write a true statement. Again, it reads as less than or greater than, so it should make sense when you're reading these. Of course, when we're using A and B, these would be values. So this would say A is less than B is red. Of course, A is less than B. Whatever number it is less than whatever the other number is. And is true when A is to the left of B on the number line. Think left is less. Okay, so and I've already talked about this, how the less than symbol it kind of corresponds with an L, kind of, and so you could think of that L for less than. Whereas on the second one, A is greater than B is red. Well, A is greater than B, and it's true when A is to the right of B on the number line. So this is only dealing with A. Of course, we can reverse this like this one here, number one. We can say, well, if A is to the left of B, then B is to the right of A. Okay, that's fine. Or on this one, A is to the right of B, which means B is to the right of A. Okay, I'm sorry, A is to the right of B, so B is to the left of A. There we go. I did that right the second time. And again, this would deal with numbers like, 1 and 10, something like this. Of course, 1 on the number line is to the left of 10. 1 is less than 10. Okay. But if this value was to the right of 10, like, let's use a different number, like 31. 31 is to the right of 10, so then, of course, we'd have to switch that so that it eats the 31. I think we've talked about the eating thing. And, if you go back to elementary school, they usually talk about this as an alligator eating the numbers, and that's fine, if you prefer to think about that. I like to think about that in terms of bacon, I guess, but however you like it, okay? Now, you can use money on this as well. We did talk about using negatives with money. So this would be like, well, would you rather have $31 or $10? Of course, the answer should be both. But if you only have to choose one or the other, yeah, of course, you choose the 31 bucks. So that's why it's opening to the 31. So we gotta fill in these blanks with either less than, greater than, or equal to symbols between these. Now this first one has negatives right there, right? Negative 14 and negative 7. Now I'm going to show this on a number line, which hopefully will help us make sense. Remember, negatives are to the left of 0, positives are to the right, and I purposely offset the 0 to the right because we're only dealing with negative numbers. So I don't really need to show all the tally marks for these. I should just know that 7 would be to the right of negative 14. Negative 7 should be to the right of negative 14 because it's a lower negative. Now what this means then is that this inequality here would be a less than symbol. Negative 14 is actually less than negative 7. And again, this should make sense. Usually it is a little bit more helpful if we look at this in money. Well, would you rather owe someone $14 or would you rather owe someone $7? Why am I saying owe? Because there's a negative value. So, well, and again, of course, the answer should be neither. Hopefully we don't owe anyone anything. But if you did, then hopefully you'd rather owe them less. Okay. So hopefully that kind of makes sense. It is common for students to make a quick mistake on this one where they're just looking at 14 and 7 and say, well, I know 14 is bigger than 7. Okay, that's true, but remember, you got to take a little bit more time on these and look at this as though we are dealing with negatives, which we are. So it's actually negative 14 is less than negative 7. Be careful on those. It's a common enough mistake where it can cause problems, all right? Yeah, and same with this next one. 4, we're going to compare 4 with negative 9. So a lot of students, if you're doing this quickly without thinking about it too much, you'd say, well, 4 is less than 9. Well, that's true. 4 is less than 9, but it's not less than negative 9. And we can even show that on a number line right here. I'm going to put 0 in the middle this time. A negative number is to the left, positive number is to the right. Well, negative 9 would be to the left of 0. 4 would be to the right of 0. It doesn't matter if they're spaced apart correctly, because this would just show that 4 is to the right of negative 9. And so this one would have to eat the 4 right there, okay? And again, this works with money also. I mean, would you rather have $4 or owe someone $9? Well, hopefully you'd rather have your $4. But either comparison works. I mean, again, if you can look at temperatures as well. 4 degrees would rather be 4 degrees or negative 9 degrees. Again, maybe hopefully neither, but if you have to make a choice, there you go. So if I was comparing 9 to negative 9, now these are opposites, right? But if I were to look at on a number line, these two values, 9 is to the left of 0. I'm sorry, positive 9 is to the right of 0, and negative 9 is to the left of 0. Yeah, on this one we would have to show that 9 is greater than negative 9. So this is still an example of less than or greater than. If we were looking at equal to, the signs also have to match. So we'd have to say something like maybe 12 and 12 like this. If you see the same numbers on both sides and the signs have to match, then we would say that they are now equal. All right, zero pairs. Now this is actually a more crucial principle than I don't know. This lesson may lead on. You're going to use this quite a bit. Not just in 950, but you're going to use it a ton. Every class after that. I mean, zero pairs are crucial. All a zero pair is if you take a number, any number, and its opposite, and you add the two together, you get 0. Okay. It doesn't matter if you took 1, right? If I said, let's look at positive 1 here. Let me mark it at 1. Let's look at its opposite. Well, that'd be 1, but negative. If you were to add these two together, boom, you get 0. Okay. Well, why is it important to get 0? It's because later on when you start solving equations, you're going to be seeing this quite a bit, and we'll see it with addition and subtraction of negatives as well, particularly addition. Sometimes the values just zero out. Okay, well, zero is crucial because we've seen, or if we haven't seen, we will see that when you get values of 0 with other values, it's possible to treat that as a phantom 0. Okay, so it's like saying, well, something that has no value to you, sometimes you ignore it, right? And I guess unfortunately we do that to people sometimes, but you ignore values of 0, and well, eventually they just kind of go away, out of sight, out of mind, kind of thing, and that's where this becomes very important. I'm getting a little bit ahead of myself here. You'll see that again. You'll see that extensively in 950 and 980 and 1010 and so forth. But they may not specifically say, well, we're using 0 pairs. This is not an academic scholarly word or phrase right here, 0 pairs, but it's something that you'll see quite often in order to zero out values. So modeling positives and negatives, it's possible to use these. They call these chips or tiles. Sometimes they're cubes. I don't know. I'm going to call them tiles, I guess. But it's a good way to model. Sometimes it's a good way to model positives or negatives, which we'll show here. So we got a positive tile here. So I'm going to use orange for that, and then red negative tiles. It doesn't matter which color you use as long as you keep them corresponding so it makes sense in your mind, right? Some people say, well, I don't like a college that's blue, so I use a blue for negatives, and I like red colleges, so red's for positive. I don't really care as long as again, it's just to help you make sense of positives and negatives. So, and I believe there's examples like this on the assignment where you got to use actual tiles like this. You just kind of click and drag them into a box in order to show how to represent a specific integer in 2 ways, like this one, right? So it's saying, hey, represent -4 in at least 2 ways. Now, the easiest way is to actually just represent it directly. So I'd say, hey, look, here's the negative, That's one negative though. Each of these tiles is one, so there's two negatives. But I need four total, right? So just double that, and boom, there we go. That would equal all by itself -4. Okay. Well, it says represent at least two different ways. Okay, so we're just gonna do two ways, and then we'll be done. Now, the thing that I know is that the total value has to be a -4. So whatever I get finally should be 4 negatives. Well, how do you get a value of -4 by adding more tiles to this? Well, that means you'd have to add values that add up to 0, like a 0 pair, like these two, right? If I combine this +1 and this -1, that's a total value of 0. And so this would work all by itself. That equals a -4 right there. But again, well, how many zeros can I tack onto this? As many as you want. So that's why they're saying, well, hey, at least two different ways. Well, it's not hard to do this. You just got to keep on adding 0 pairs. And some students are like, well, I want to add a positive over here. Okay, if you do that, just remember that you're gonna have to take away a positive on this side, like this one. Okay. So this still shows a value of -4 because, well, you'd have a 0 pair here and here and here and here. So all you're left with is 1, 2, 3, 4 negatives. Boom, it has a value of -4. So I don't know if that helps. Sometimes it seems like it causes more confusion, but I hope it helps you to understand because, well, what is this right here? It ends up being addition for us, which we will see. So ordering values from smallest to largest, the number line, again, we've seen this, the number line can be used to make these determinations. Just remember, numbers that are to the right on the number line are bigger, no matter how you may think they are. It's all based on where they are located on the number line. And yes, it's crucial to remember that 0 is right in the middle, positive numbers are to the right, and negative numbers are to the left, as long as you're using a horizontal number line. Of course, you're still welcome to use a vertical one, but we're going to be using a horizontal. So here we go. We got 1, 2, 3, 4, 5, 6 numbers right here, and we're going to order these from least to greatest. But it will be helpful to remember that we're dealing with both positive and negative. So positive numbers to the right, negative numbers to the left. So the first thing I like to do, especially with smallest to greatest, is to start with numbers that are smallest. Well, smallest indicates left to right. And so I would start by just analyzing my negative values. So I see I got -865 here. Let's set that aside. And then also this -833 here. Set this over to the side. And -346. Set that over here. And then also -243. Now let's set this to the side. So I got 4 negative numbers. The other 2 values are positive, yeah. But these 3 negative values. So remember, we're just comparing these, and do remember that the bigger the negative, the smaller it is technically because it would be farther to the left on this number line. So I'd say look at these 3 values here. 4 values, and look at the number. They're all 3-digit values. So we're looking at the hundreds place values. Whichever the hundreds place values is biggest is the smallest number. So I'd say I got these 2 numbers that have 8 in the hundreds place value. 8's bigger than 3 and 2 in the hundreds. Okay, so they match in the hundreds. So let's go to the tens place value. Okay, again, the bigger number is the smallest because we're dealing with negatives. 6 is bigger than 3, so 865 is farther to the left on the number line than -833. So these are the first 2 smallest numbers. And then we look at the other 2 negatives. Again, in the hundreds place value, 3 is bigger than 2, so it would be the next smallest, or next biggest rather. And then, of course, just by the process of elimination, now we have -243. So these are the first 4 numbers in order from least to greatest. Okay, so we used up all the negatives in our list. All that we have left is the positive values, which are 933 and 276. All right, so this is just straight comparison, which we've done with positive numbers before. And both of these are 3-digit numbers, so I'm looking, starting in the hundreds place values, whichever them is biggest is the bigger. 2 is smaller than 9, so it would be the next biggest in the list. And then the biggest of them all is 933. So I put commas between these, I box it in, and that is these 6 numbers in order from smallest to largest.